Okay, so we were doing a few questions on limits only, and so we are going to continue in this session also, uh, use by solving a few more questions on limits only. Okay, so once I'll be doing these limits, I'm again going to revisit the entire chapter and probably do a few more things that are more fundamental and with regards to different other competitions which are also there except JEE. So you can also give a central an exam for a Chennai Mathematical Institute. You can also give an exam of Indian Statistical Institute. So all those exams are there, and they've got some very concrete and slightly difficult problems than what usually JEE has been asking for all these years. Okay, so let us do that question from Chennai Mathematical Institute. So this is a question that was asked, if I correctly remember, in 2012. Okay, so I'm going to write down that for you, and let us see if you're able to do it. So it was asked in undergraduate exam for Chennai Mathematical Institute in 2012, if I correctly remember. And let me just give me a minute, so that if I retain it, I don't want to do any problem while writing it. So just give me. Okay. So if I'm not wrong, so this was the question, I think. So one needs to find what would be limit x tends to infinity, x raised to power 100 ln x divided by e raised to power x tan inverse of pi by 3 plus sin x. Okay, so I'll do it for you, don't worry. If you remember something from your inverse trigonometry, then always remember that for all x belongs to R, your tan inverse x, be it whatsoever, it will always lie between minus pi by 2 and plus pi by 2. I think this you are aware of this. That for any real value if you want to take, your tan inverse will always lie between minus pi by 2 and plus pi by 2. Is that clear?
Yes, sir.
Okay. Okay, so this is very much clear. And for all x belongs to R, you can also write here that your sin x will always lie between minus 1 and plus 1. Okay, so your sin x would always lie between minus 1 and plus 1. So even if x tends to infinity, your sin x would rapidly oscillate between minus 1 and plus 1, but overall it will be lying between minus 1 and plus 1. Is that clear?
Yes, sir.
Okay, and if you slightly know about increasing and decreasing functions, so if your function is differentiable, and if I just try to find the derivative, and if it is greater than 0, then I can write that I'll write if my function is defined from an interval I to R and fx is differentiable, if x is differentiable and f dash x is greater than equal to 0, then fx is said to be an increasing function. This is something that you know or don't know. It's said to be an increasing function. Is that clear?
Yes, sir.
This is you know, this is something that you don't know.
No, sir, I know this.
You know. So f of x, if it is tan inverse x, you can write that your tan inverse x being f of x being tan inverse x, your f dash x would be 1 upon 1 plus x square. And you can clearly figure out that your tan inverse x is an increasing function. And why I'm doing this, I'll let you know. So even as x tends to infinity, your sin x would rapidly oscillate between minus 1 and plus 1. So minimum that sin x can attain is minus 1, maximum that sin x can attain is 1. Like it will always oscillate between minus 1. Okay. And because it oscillates between minus 1 and 1, its limit cannot be defined as such, but you can say that it will lie between minus 1 and plus 1. This is certainly the last thing that you can conclude from here. That is, x tends to infinity, your sin x would oscillate between minus 1 and plus 1. And your pi by 3 plus sin x would obviously be actually you can write that pi by 3 plus sin x will lie between pi by 3 minus 1 and pi by 3 plus 1. And since your tan inverse x is an increasing function, so another definition of increasing function is that if your x1 is greater than x2, and if f is increasing, then your fx1 is greater than fx2. This is something that I would need to remember. Actually gave a question, but if you know that if your x1 is greater than x2, and if your f is increasing, then your fx1 would be greater than fx2, and therefore you know that your f, whenever I say it is increasing, keep in mind these are order preserving functions. By order preserving functions, I mean that whatever the in whichever way your arguments are ordered, if you impose functions over it, then function will also will maintain the same order. Is that clear? Harshit, is that clear?
Yes.
Okay. So I'll write that my tan inverse pi by 3 plus sin x would lie between some, I'll write, let's say, tan inverse pi by 3 plus 1, and this will be 10 pi by 3 minus 1 here. Okay, so this is fine. So this is something that you are aware of. Okay, and certainly, if you want to make a graph here, so I'll make a graph for you. How does log x, how would you make a log x? So you'll make a log x like this. And how would you make x? You'll make x in this fashion. Okay, so clearly for all x greater than 0 from graph itself, and otherwise we'll prove it by using differential calculus as we go along in our course. But you can see that for all x greater than 0, your x is way too greater than ln x. You can see that ln x is less than x. Is that clear? This is your fx equal to x, and this is ln x. So for all x greater than 0, that is for all positive x where a log x is defined, you can see that your x is greater than ln x. Is that clear?
Yes, sir.
So what I'll do, and why I'm doing all these things, you'll come to later on. And you see, you wanted to find limit x tends to infinity. So I'll write again limit x tends to infinity. And I think you had this x raised to power 100, and then you had ln x, and then you had this e raised to power x, and then you had this tan inverse pi by 3 plus sin x. Okay, so if I want to write here that what would be 1 upon tan inverse pi by 3 plus sin x, obviously it will be less than 1 upon tan inverse pi by 3 minus 1. And it would be greater than 1 upon tan inverse pi by 3 plus 1. Is that clear? If I do it 1 upon, so if x is greater than y, then 1 upon x is less than 1 upon y. This is something that you know. Is that clear? So
Yeah.
overall, I can understand that this would be positive because x is positive. Ln x, as x is tending towards large number, ln x is also positive, e to power x is positive, and tan inverse, if I write this, this will also be positive because are you getting my point? Because see, tan inverse x always lies between -1 and +1, and pi by 3. If you remember what is pi, pi is almost, if I even approximate to 2 decimal digits, this will be 3.14. So this is greater than 1. So pi by 3 would be greater than 1. Is that clear? Even if sin x becomes -1 also, it will be again positive. And you can see that for all x greater than 0, your tan inverse x would lie between 0 to pi by 2. Is that clear? In any case, this is positive. This is always positive. Ln x is positive for large x. You can see the graph. Ln x, if it is increasing and beyond x equal to 1, at 1, ln 1 would be 0. But beyond x 1, you can see that for all x greater than 1, your ln x is positive only because it is lying above x-axis. So in any case, this would be positive for large x, and this is positive. So one thing that I'm very sure is that I can write that my x raised to power 100 ln x divided by e raised to power x tan inverse pi by 3 plus sin x. This entire thing in any case would be greater than 0. This is for sure. And on another end, you can write that since, see, I have written that x is greater than ln x for all x greater than 0. So even as x tends to infinity, this will remain the case. So for all x greater than 0, you can see that your x is greater than ln x. So even as x tends to infinity, your x would dominate over ln x. Is that clear? So your ln x would be less than x. And this x raised to power 100, I'm not writing, but I'm writing that ln x would be less than x. Is that clear?
Yes, sir.
and then divided by e raised to power x, and this would be some constant. I don't know, like this will be, I will write once for a while, I'll write this is 10 pi by 3 minus 1. But then I will write that, okay, because overall this would be a constant. 10 inverse pi by 3 minus 1, this would be some constant. Is that clear?
Yes, sir.
I'm not bothered about it. Let's say it is some constant k. And this is x raised to power 101 divided by e raised to power x. And then you have this x raised to power 100 here. And then you have this ln x divided by e raised to power x. And then you have this tan inverse of. I hope it is clear.
Yes.
And now you see, always remember, if you have a polynomial and it is divided by e raised to power x, polynomial divided by e raised to power x, and if you want to find limit x tends to infinity, this limit always comes out to be equal to 0. Why this limit comes out to be equal to 0? Let's say if your polynomial is of degree n. So if I talk of highest, if I talk of x tends to infinity, all you need to see is the highest power. All you need to see is the highest power. So let's say if it is of a polynomial n, a polynomial of degree n, then I'll approximate px as x raised to power n divided by e raised to power x. Since this is limit x tends to infinity, this will become infinity by infinity form. Is that clear? So
Yes,
what
sir.
you'll do, you'll use L'Hospital rule. So once if you use L'Hospital, you will get n into x cube power n minus 1 e raised to power x. Again, you see, if you place x tends to infinity, this will become again infinity, again you will end up getting infinity by infinity. So when you will get rid of infinity by infinity form, you can only get rid of infinity by infinity form by differentiating it n times. By differentiating it n times. Numerator and denominator. The denominator will remain e की power x because e की power x, any number of times if you differentiate it, it will remain e की power x only. And the bracket on the numerator side, you will find n into n minus 1 into n minus 2 dash 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 3 to 1 divided by e raised to power x. So it will be equivalent to writing n factorial divided by e raised to power x. And you can see that as x tends to infinity, your e की power x would tend to infinity. N factorial divided by tending to infinity, you'll see that this particular thing would be equal to 0. Is that clear?
Yes, sir.
No, sir. Yes, sir.
Yes, sir. Yes, sir.
Yes, sir. So x raised to power n, did you get my point? So if you differentiate it again, let's say, so you'll get n into n minus 2 x की power n minus 2. Then
Yes,
again
sir.
differentiate, you'll get n into n minus 1 into n minus 2, and then x की power n minus 3. So if you keep on differentiating that way, you'll find that the numerator will become n factorial, the denominator would become e की power x. Overall, this particular term will go towards 0. And on the left hand side, it is also always 0. So by Sandwich theorem, I can write that my limit x tends to infinity, x raised to power 100 ln x divided by e raised to power x tan inverse pi by 3 plus sin x. This entire limit would become equal to 0. Is that clear?
Yes, sir.
I don't think now it will haunt you. I don't think it's going to haunt you now. Okay. So we'll do another question. Is that clear ना? ये चीज समझ में आ गई पक्के से? I don't think
हाँ,
it's
sir.
okay. Good. चलो एक मुझे दो and I'll write a question for you. In meanwhile. Just give me a minute. Okay. So try to do this question meanwhile. Okay. This is another question. Try to evaluate this limit. Limit a tends to infinity, and you have e की power 1 upon k divided by k square plus 2 e की power 1 upon k का whole square divided by k square plus 3 e की power 1 upon k का whole cube divided by k square and e की power 1 upon k की whole power k divided by k only. Just try to do this. Did you get some answer to this? Or is it a difficult problem? Even I think I've given a little bit difficult one. Harshit, are you there? I mean, uh, okay. Do I need to do this? I mean, मुझे करना ही है? Uh, okay. Yes, we've lost the connect. Okay. So I hope this question I'm going to continue tomorrow. I think we've lost the connection right now. So I'll do this problem in the next meeting. Okay. So I'll do this problem in the next meeting.